Hi, and thank you for joining. Let's continue with some examples where we have to practice the derivatives of logarithmic functions. Recall that the two formulas we just learned are the derivative of log with base a of x is 1 over x ln a, and the second formula is the derivative of ln x is 1 over x. Let's get started with the first example. We have log with base 3 of x, which means that the derivative dy dx equals 1 over x. That's what we have inside. And multiply this by the ln of base 3. So 1 over x ln 3 is the answer. Next example, we have log with base 2 of 5x. So the derivative of it will be 1 over 5x multiplied by ln of 2. That's the base. And remember that here we also have a chain. That's because inside the log we have a function with a derivative different than 1. So that means we have to multiply by 5. Simplify. So as you can see, 5 and 5 here will simplify to 1. And the answer is 1 over x ln 2 dy dx. Let's continue with the next example. Try on your own first. It's more fun always. Dy dx equals, so in this case we're using the formula for ln of x. So we have ln of 7x. So we have the outside function, which is the ln function, and the inside is 7x. So we'll start off with the outside function, which will be 1 over 7x, multiplied by the derivative of the inside, which is derivative of 7x, which equals 7. And surprisingly, you see that they would simplify 7 and 7, and simplify to 1 over x. This is the same as the derivative of ln of x, something to think about. Why does that happen? So next we have y equals ln of x to the power of 3. So you have an outside function, which is the ln, and inside function is x to the power of 3. So dy dx equals, so the outside function is 1 over x to the power of 3. The inside function is 3x squared. Simplify, so we have x to the power 2, x to the power 3, simplify to give an x, so we have 1 over x. So dy dx equals 1 over x, and then multiplied by 3, or simply 3 over x. So let's continue with the next example. This time we have y equals ln of 5x minus 3 divided by 2x plus 1. So we see quotient rule here. Okay, and that means that we need to differentiate the numerator first and multiply by denominator minus derivative of denominator, multiply by numerator, and bring this to the power of 2. So let's get started. Now, always keep in mind that these two are different functions, so we use different differentiation formulas to differentiate them, right? So we have dy dx equals, we're still going to have the big fraction line. We have the difference of the two terms here. And the derivative of ln 5x minus 3. So for this, we have an outside function and an inside function. So we'll have to take care of them one at a time. So that would be 1 over 5x minus 3 times the derivative of the inside, which is 5. Wait a second, we're not done yet. We got to multiply by the denominator 2x plus 1. And then minus. So we are minusing the derivative of the denominator, 2. Multiply that by ln of 5x minus 3 over 2x plus 1 to the power of 2 equals big fraction line. So we're going to bring these two together, right, to write it in a more, cleaner, neater form. So we have 5 times 2x plus 1 over 5x minus 3 minus 2 ln of 5x minus 3 over 2x plus 1 squared. Now, this is not the most simplified form of this derivative, and that is because we have fractions inside fractions. So we have to write the entire thing as a single fraction. So first we have to combine the terms in the numerator. So this will be over 1. And we'll multiply by 5x minus 3, which is the lowest common denominator, both top and bottom. And that will make the denominator and the numerator, well, the denominator is the same, obviously, but the numerator now will change. Let's simplify. Big fraction 9. So we'll have 5 times 2x plus 1 minus 2, and I'm going to bring that 5x minus 3 to the front of ln, and then ln 5x minus 3. And all of it over 5x minus 3. And that would be over 2x plus 1 squared. So let's see what else we can do here. Equals. So we'll write the numerator first. So we'll expand in the meantime 10x plus 5 and then minus. You can bring number 2 in. So that would be 10x minus 6 and then ln of 5x minus 3 over 5x minus 3. Now it's time to divide by 2x plus 1 squared. So turn division into multiplication, and this will flip. So that would be 1 over 2x plus 1 to the power of 2. So we'll bring everything together in one single fraction. That would be our last step here. So we have 5x minus 3, 2x plus 1 to the power of 2. The numerator has 10x plus 5 minus 10x minus 6 ln of 5x minus 3. And as you can see, the derivative turned out to be a lot more complicated than the function. And that's the way it is. And that's what the derivatives of log will often look like. So let's continue with our next example. This time we have y equals 4x plus 3 ln 5x. So in this case, we have the product rule. So we'll start off with the first factor here, the first derivative here. Let me see if I can do this. Yes, I can. So we have dy dx. Oopsie. Equals. Derivative of 4x plus 3 is 4, and then ln of 5x. And then plus, because product rule. And now we have a ln of 5x derivative, which will be 1 over 5x times the derivative of inside, which is simplified, and then times 4x plus 3, the other factor. So just so that we can spot what we differentiated. So this is what we differentiated in the first group. This is what we differentiated in the second group. Now we clean up the expression. We have 4 ln 5x plus. Now 5 and 5 will simplify here. Oopsie, this way. Okay, and we end up with 4x plus 3 divided by x. And this is good enough, I would say. If we want to write it in a single fraction form, would be 4x ln of 5x plus 4x plus 3 over x. And that would be the answer for this derivative. Let's continue with another example. This time we have implicit differentiation. So I will start by rewriting the equation first. So we have ln of x plus y equals y minus 1. So we are taking the derivative of every term. So first try to identify what terms we have. So we have a single term here, a long term, and we have two terms on the other side, the difference between two terms. So we'll start by ddxing each side. So here we go, ddx ln of x plus y, and then ddx y, and then minus the derivative of 1. So we are ddxing basically every term. So the derivative of ln of x plus y, we have an outside function here. So the outside function is the ln. The inside function is the x plus y. So we're going to go slow here, one step at a time. So the derivative of ln would be 1 over x plus y times the derivative of x plus y. Now, derivative of x is 1 plus derivative of y is dy dx. Close brackets, equals. The derivative of y is dy dx. And then derivative of number 1 is 0. So we'll write the expression a little bit more neatly here. So we're multiplying a fraction by this known fraction, and I'm also writing dy dx as y prime. So we have 1 over x plus y multiplied by 1 plus y prime equals y prime. So let's make y prime green. It's a beautiful color. All right, so even better, we have 1 plus y prime over x plus y. Obviously, you can simplify a lot faster, right? I'm just trying to show every single little step. And you see that we have a fraction on both sides, on one side, but a known fraction on the other. So we'll make it a fraction. We'll cross multiply. So that will bring these two together, this two together. So we have 1 plus y prime equals y prime multiplied by x plus y. The goal is to isolate y prime. So we'll take y prime terms to one side. So 1 equals, we have y prime, x plus y, and then minus y prime here. Factor out y prime. It deserves it. Here we go. And we have x plus y minus 1 here. Now we can isolate y prime by dividing both sides by x plus y minus 1. And voila, we got y prime. And y prime is equal to 1 over x plus y minus 1. And this would be the derivative of this function. And in the next example, we are going to take a look at finding the equation of the tangent line. And for this, I'm gonna see you again in the next video. Well, I hope this made sense and was helpful. Practice as much as possible. Practice makes perfect. And thank you for watching again. Bye for now.